Hello everyone, and welcome to our tech session today. Today we are going through Frameworks 101. We have 3 key canvases which we'll work through today. And the aim of the tech session today is essentially to kind of do a workshop style walkthrough of how you should populate these canvases, the different aspects you should look at and consider, really understanding why you would use these canvases. These canvases bring together tech and business teams to be unified on one approach to solve a use case or a project. So Nicola Jay, myself, and Jess are going to be looking at the ML canvas and the prediction story canvas and going through how you would use these and unpacking the different elements to them.
I think it's probably safer if Jay presents, but I think he's just, oh, you back online. Okay, there you are.
Present the
mural. I can get to it as well. I've got it open right here. The link is in the chat as well for the guest mural.
I just need to log in quickly.
Okay, cool. In the meantime.
Let's try to, let's have to get that. Sorry, that was a bit of a surprise. I didn't have anything to present today.
Apologies. I think I presented the last time, so I'm happy to present now.
Oh, there we go. You got it up.
Yes. Yes. So this is, and everybody in the call already has access to this mural, so you can join in and work along. It should be pinned in the chat. For those that joined a little bit later, please let me know if you can't see it, and I'll reshare the link. So what we're going to be looking at today is top layer over here, which is the business layer. Okay, so one of the places that we start is by looking at the prediction story and, you know, what that sort of means. I'm actually not sure. I think that it is something that is quite ecosystem specific. Jay, is it something that's used quite widely across most of the tech spaces? Is quite specific to us or to you?
I think it's specific to the work we've been doing with clients, because what happens if you think of a user story and an agile process, it doesn't help you in any way to define when you do anything that is predictive. So the idea behind the prediction story is that you have a separate way to describe the functionality that you need to perform a certain action that is predictive in nature. So think of language models. If you look at its X and its Y and its benefit, it predicts a token from a priorly trained transformer in order to provide you with useful language. That's what a language model is. So that means that it predicts the next token, and doesn't mean that the way that it's going to be applied in business or commercially or its various styles of use are defined in a prediction story. The prediction story is just the core of what you do, and that's why you need more detailed than just having the prediction story that's mapped to a user story in a particular delivery cycle. You need additional description of what you're going to do around it.
I have a question that came to mind when you were talking about determining what is predictive in nature. Could you break down how you identify something as something that can be predicted?
Well, we have events that have happened already, data points stored about historical activity, your bank balance last month, your driving patterns a year ago, how much money you saved 2 years ago, or how much you spent on your mobile phone an hour ago. That's anything to do with the past. And that means if you want to fetch any data or find evidence of what you've done historically, it's not really a prediction if you want it returned 100% accurately. But let's say you've got all of this collected, and if you think about going into the future, predictive means I don't know what's going to happen next. and I want to automate a probability as to whether a certain event's going to happen, or I want a propensity score assigned to a list of products I'm going to present to customers, that's about the future. And that means I need to infer values from the past, create a model, and that's what a model is, to predict what's going to happen next. So I cannot have, let's go back to our language, a generative model and let's say any kind of, unsupervised or supervised learning model alongside that. But let's just think about, if I have a language model that's only ever been trained on all words except the word "the," think about how important this is. And when you're trying to use it, it's not present. It can't make it up because there is no evidence of it anywhere in its input data set. So you have to make sure that what you're going to be using it for, if it is something that predicts the future based on the past, then your decision to implement that as a lookup is not possible. You have to build a prediction because it hasn't happened yet. Now, the various ways that you could solve a futuristic predictive problem. And the prediction story might say that I want to dynamically adjust to Nicola's behavior of her spending in order to service her better for my bank. The moment you have anything to do with a dynamically adjusted or anything that has got a variance based on something that happened in the moment, you now need to think about dynamic models. So it means its prediction is instantaneous. It's within a millisecond, but it still will take into account potentially what you did the last hour or the last month or the last year. And it does all of that in real time and then decides how it's going to service you better. And it means that anything that is not yet determined or is some kind of varied output, that means that it will be a prediction.
So I think that actually answered a question that I was going to get to. I just want to share, I know that a lot of people have access to this, but I just wanted to share this piece over here to just talk about the three different approaches that we had with regards to when you actually start building. It sounds like the prediction story is very applicable within the static model space, right?
It's used for all three of them.
Okay, so that's what I wanted to ask about. You spoke about the static models and the dynamic models. And in terms of generative models, what is one of the examples that we could use? Because you gave us examples of these two.
An example that if you think of an agentic journey, a series of agents that fire off value they're going to derive from tools. The prediction that you're making is that you need to predict the intent of the person or of whatever the application is that you've created, the workflow, to execute on something or not. So that means that I need to predict the intent so that I can ensure that my journey stays successful. So you still use the three-part story to give you an understanding of what you are working on. And it helps your analysts to have a common description and a common taxonomy of the language that they'll be using for this. So it gets applied across all kinds of model types. And I think that the thing is that once you get into the canvas, that will be one of the key decisions, is to say, well, the value that I'm going to get from this prediction story is now described on the canvas in a bit more of a business tone. And in there, depending on what approach you eventually decide, if you decide the static approach means that all the prior data is in evidence to predict what's going to happen next based on a batch cycle. And that means that if that is your decision, it will affect your canvas, because in your model section and in your feature store section, it will be different than if you see that the model type that's solved your problem is more dynamic because you have a human in the system and you've got behaviors changing all the time, then it'll be different. So I think you probably play it out as an analyst in the canvas, and you will then decide what you think is most appropriate for your case.
I think that perfectly encapsulates how business logic can map directly onto parts of the platform or the workbench we're working with, what you're using as a knowledge base to predict a future event on will determine what your data sources are going to be.
Yes.
And how you process those sources will determine how far into the future you're wanting to predict. So it's like essential, especially because our product is such a wide range of tools, you need a way to channel different tools to work on a specific use case or business problem. So I think that kind of encapsulates why the prediction story is important. I think maybe we can move on to the machine learning canvas, unless Jess, you have something to say?
I do. I've just got one more question with regards to the prediction story part of it, especially in light of the session that we just had now with regards to the data scientists. Like, is there a specific role that is better poised to be in charge of the prediction story? Or is it something that is better put together as this sort of team collaboration where everybody, you know, works together to define the basis of the case? It sounds like this is a great way to frame the use case you're actually about to embark on.
I definitely think it is done at the most senior level possible. I mean, we've had CEOs of divisions or business units in a room when we discussed what they need to predict about their future. Because if you're going to want to predict supply patterns or what product to sell to what customer, inevitably it ends up in some kind of senior conversation. And the reason why the story is crafted the way that it's crafted is that it is understandable for somebody to predict if the sun's going to come up tomorrow from historical data. So that means that it is quite easy to map the story onto something that is not compute related or that is not about a technology. It can be about anything in life. Because if the person who likes to go, let's say you go to see a fortune teller, they are predicting your future from what they see in front of them, for whatever reason they give you, to make you feel comfortable. That concept of prediction is that humans are prediction machines. We're trying to predict where we're going to go next and what people are going to say. We even get levels of anxiety because we think that somebody else is going to behave in a certain way. We predict what they're going to be doing. In other cases, you might use your gut and it's going to come out perfectly, and then it strengthens your view of the future. So that means that anything that's unexplainable, or not something you can look up, means it's predictive. As soon as it's predictive, it comes with a risk and an understanding that you are going to apply it properly. And that's why you need to do further thinking to explain what it is you're going to be handling from a prediction point of view.
Great. So I think we glossed over this a bit in the last session, this machine learning canvas. So it's a kind of ecosystem take on the Louis Durard machine learning canvas. Jay, maybe if you can explain a little bit about the high level structure of how it's divided, like the white and the gray, and why it's been put into the specific order, and then we can go into each individual section.
Yeah, great. We inferred that the reason why Louis did this is to give people a recipe to follow the dots or to fill in the gaps to get their reasoning to a point where it makes sense for what they want to do. And if you think about any framework for that matter, remember we're talking about conceptual frameworks, not software or hardware frameworks, but in this case, the ability to take your learnings, put it into an environment where somebody, by just looking at it, will be able to get an understanding of what it's about, is what I think most Canvas designs have come to. So if you use the business model canvas, value proposition canvas, or AI deployment canvas and the like, it is just that in this case, we quite like this approach because you got to the right of the center, you've got data, evidence, historical capabilities, and preparing your view on what you're going to be doing in the future. And everything on the left of the center line is anything to do with what's coming, where it will be used and how it will be validated and how it will be checked over time. And I quite like that construct because if you think of the business canvas, we've got, to the right of the canvas, everything is to do with channel, customer, and segments. And to the left of the center line is anything that's got to do with how the company is internally. So I think that notion is what resonated with us. The other thing is that if you translate the prediction story into a value proposition, and you'll see there that it's plural, it means that you might end up with a number of different value points that's going to deliver on your delivers your prediction story. It's hardly ever a one-to-one relationship. So if you're going to, and let's take a classical example of what we did with recently. I want to predict a customer's behavioral trait from the historical data to understand you're going to communicate with them better. Now, how do you turn that into something that's valuable? The value of the prediction story lies in what you're going to be doing with it. And the canvas helps you to describe how you're going to get to that point where you know that it's going to do what you need to do. So that's why we think that starting with a value proposition, having that at the top of your business case or business example or whatever it might be that you're going to document for a client or use yourself, that normally gives you a first kind of great view of what you want to do. So the value proposition could be, I want to sell more to a customer. I want to retain a customer by talking to them better. I want to be able to sell additional products to them by understanding their personalities better. So the value proposition can be fairly broad and then narrow down to specific points depending on how you're going to want to validate it. Because eventually you would want to validate each of your value points when your model gets evaluated at the end of its cycle. So then, now if you think about then the white versus the gray in this chart, there's maybe a little bit of a white missing, and that's number 6. It should be part of the white too. That means that's the business view. The business person, foremost, wants to understand what value they're going to derive from the case. Do they have in their business an ability to collect the kind of data, or do they have the data that they're going to be using? There's a big fallacy that business people don't understand data. They understand it very well because every single business person at some point helped their company design a form. And that form ended up in a file, in a cabinet, in a room somewhere that somebody had to find. The principle of data, I think, is in all my business clients are incredibly well understood. They understand that the people supposed to manage the data for them don't understand because they've got a very specific view around how they want to store it and access it. Technical people look at it and say, well, no, this is a technical problem, when in actual fact it's not. And that's what this helps you to do. It helps you to discuss what evidence you're going to get. Is that evidence acquired reliably? Is that evidence stored consistently? Can I use it by the time I go into my more technical deployment, like the feature store, that it's going to do what it needs to do? But I first need to understand that. The other thing I need to understand is, what am I going to do with this thing? Where will it be used? Who's going to benefit from this? Is it a person who's going to click a button to run some prediction and generate a graph for them? Or is it something that's going to impact the customer the moment they sign up with a product that's going to display a message in real time? So that means that way in which that prediction is going to be used is an enormously important thing to understand, because there are, in many cases, vast misunderstanding that plays out when people build out these kind of capabilities. Because in most cases, you would need a number of different approaches to get your models presented. Because if you have something like an example we used earlier, I want to predict a customer's behavior, and I want to then be able to sell them a product or provide them with a message specific to their personality. The data that I collect will be transactional, and then I would have to run a model at the bottom, but the outcome would be, when I use it, I mean, is it really interesting banking customer to know its personality, or for you when you listen to your Spotify? Probably not. It's probably useful when I know that the marketing campaign is running a story to all of their customers, and they want to make sure that they speak to them in a way that is specific to that particular group. Then it becomes a different thing. So that means that the prediction stories, implementation being the outcome of the prediction, then used in a process or used in a technology where it will be realized. Think of the concept of a GPT, of a generative pre-trained transformer. A GPT becomes useful because you bolt a chat model onto the front of it. Then you bolt a chat engine on the front of that. That's got the user interface and all the technology built in that area has got nothing to do with the prediction. The prediction of predicting the next token is one tiny moving part in the total story. And this canvas deals with one portion of that being a prediction story. And that's why number 3 is like your primary focus before you get to 4. In some cases, you'll do 4 and 1 together, where, sorry, the bottom 4, the small 4. This in the behavioral approach. Now that you will create a capability that is from the beginning potentially behaviorally enabled. And then the only way that the business person is going to know if this is going to work is once everything is done. In number 6, can I see what's going on? Can I actually track my benefits, track my profits of what I've implemented? So that's why we kind of separated the white from the gray. But in early steps with getting a business story, you need at least 1, 2, 3, and small 4.
Cool. And I think I remember we shuffled around the data enrichment and data sources section a bit. Could you maybe explain a little bit about what happens in that section?
Well, the thing with any data ingestion is, in most cases, it's a technological challenge. Data cleaning is a technological challenge. Data updates and moving data around or obtaining it from wherever you're going to be obtaining it from. And then you need to think of data in motion versus data that is stationary, depending on how long it's going to be in a certain place before you use it. All of those areas are discussed, especially if you think about your data sources first. You want to understand from your sources, is this data going to come in on a stream? So that is it a real-time inbound event that needs to trigger the prediction and produce the value absolutely in the moment, provide a recommendation when you check your balance on your account, as an example, is very different than somebody sending a message, 6 in the morning from what process the day before. It's got a different flavor of how you would do that. But that means that the data is very closely related to sources, to your value propositions. And the same thing with the decisions on the left. When you look at number 3, the ML task is less important to the business person, the same way that the data enrichment is less important. Can I get the value? Can I get the data? Do I know what value I'm going to derive from it? Can I get the data? And can I make a decision that is the outcome or the output of my scoring of my model? The data enrichment is mostly for an interface into the engineering world, because you want to enrich by date. But if you think about the data analyst, you want to take a single date, especially if the date is sensitive, you buying certain kinds of products or you travel on public transport, whatever it might be, the date and the time is very important. So date enrichment, by knowing the day of the week of the month of the year, the time of the day, all those, let's say, enrichment capabilities for just dates, and in the cleaning that goes with that. Business people are sometimes interested in that, or people who are really driving the machine learning canvas. But as an analyst, obviously you are very interested in that, because you want to, as an example, if you want to create a time series data set from historical transactions, and you know that you want to create a one-hot encoding environment for, let's say, training a model. And one-hot means that, let's say you sell 100 products, and for every customer you have essentially this massive matrix that gets created where you've got 100 columns, and in each column that the customer has bought, there's a score assigned. That score could maybe just be binary, or it could be the number of times you've interacted with it. That kind of processing is all enrichment. That definitely helps the analyst when they decide if this case is doable. If you've got too many variances in your data, then it's not practical for you to use that. By the time you've gone through the model training, only then will you truly know the accuracy and recall, but you before the time want to discuss the ML task. You want to figure out what those steps are that the model is going to be bolted into before you then put it into whatever decision you're going to apply.
Okay, great. Yeah, I think that cleared up a few things. I just wanted to look at that little blue circle. Jay, I'm not sure, or Jess, I'm not sure if you can pull up the diagram in a bigger format, but maybe Jay, you can run us through what that is.
Just let me know which one you want to look at and I'll zoom into that one. Otherwise, I'm happy to do a high level.
It's the one that's on the canvas there, that business cycle one.
Maybe just all three. I'll give a quick background to this. So anybody who's going to implement any kind of case will know that there's quite a bit difference between your static, dynamic, and generative models. And you really want to have a different discipline around how you're going to implement it because they require different ways of thinking. In your static model, most of your thinking, especially your data cycle, is related to how you think about that enrichment discussion we just had. So that means that is there a way that I can get my priors into a format to train a model to make it static and then to go into inference is what a static process is about. By the time we get to dynamic, you now have complexity that plays out. And actually, like many bits, but let's just look at two of those specifically. The first is the way that your data is obtained for cold start priors to be calibrated is about the same kind of exercise that you might do with a static model. But the moment you've done it, depending on the algorithm, the scores start getting updated depending on if you have time parameters and other kind of things set. So that means that your data acquisition and your data generation is far more intense than in a static model. The second thing about a dynamic model is that it is dynamically adjustable in production. What does that mean? That means while it is live and being used by people, somebody with authority can adjust key parameters. You could change your date and time, windows, certain scores or priority. You can do different things with it while it is in production and live, where you never have to deploy it. And because of that, you have got those two cycles of green that you see on that chart. They are very different. The third one is the generative models. And in generative models, there's a different mindset in that from the beginning, I have to make a decision if what I'm working on needs to be explainable or not explainable. If it needs to be explainable, then I can't use generative. If it has to be explainable, and then maybe for regulation, for scoring, then it has to be discriminative. So that means it needs to be a different type of implementation that I'm going to be following. So that means that if I build something that's going to be conversational and extract knowledge from my emails and company documents and then organize them, pass them back to the customer. Let's not even talk about agent-based deployment yet. Your data now is unstructured. So you don't have data pipelines the way you have on other platforms. If you think about a high-frequency company like a bank or a telco, you've got millions of entries being created that are structured, where in the unstructured world, the number of contracts that you sign with customers, the number of emails that you have sent, not a real-time problem, but a near real-time problem. So you still have the data ingestion, but now you don't have the same model training that typically would do. You might do fine-tuning. It's highly unlikely you're going to train a full generative model from scratch, but you might train a model that is a deep learning model from scratch. So all of those decisions come into play, and then that just means that there are many different steps that you need to follow depending on what you think the solution is going to be. I think that it is probably the biggest risk that analysts, data scientists, technologists have to live with, is to say, well, you might pick one approach that is typically the least risky. And the moment you start scoring and you see that its performance can be improved, you create another model type and test. You do an A/B or multivariate. And you keep evolving, and that's why all three of these are circles. They are never-ending journeys of you evaluating what can be done better again and again. You never stop. That's why in some of the previous sessions we had, people are worried about technology lock-in. You can't, because you are locked into your Python. And actually, you're locked into the screen you're looking at. You're locked into Google that we use for call, or or any of your tech. So that means that can you easily switch from one to the other? It is also not so easy. I think that the value that you get from reassessing, reevaluating continuously, not just in product world, but in your data and your life cycle world, is what these things represent. You might have one cycle that's got your custom algorithms built, and we assist clients often with that to build their own custom, not even doing it in our environment. Then I realized that why am I doing the same thing over and over again? Why am I building algorithms that somebody else already implemented? Why do I have to do all the experimentation when I've already proven it? Those questions then can play out through a multiple view of the cycle. So that's why you just continue to do it, you know. And because it's about a prediction, is also why you would permanently sit in a loop. You can never break out of it because it needs calibration, data drift, model drift, behavior drift, interaction change drift, whatever is going to change, you need to update.
Just to check my understanding and to maybe close that loop a little bit here, like these approaches will ultimately help you to populate and to understand what could happen or be put onto the machine learning canvas, right?
Yes. So you'll see on the process, if you go back to any one of those three that we had earlier, but let's pick static first, you'll see that point number 1 says hypothesis, and that's on your AI or your machine learning canvas. That means identifying and describing your business problem, understanding of what it is, and then be able to define your use case. Means that you probably will, before you even kick off this cycle, have a canvas ready. Imagine flattening them out and then assigning time to each and every single block, and then putting that into your project plan. So that means that this is the behavior where the canvas is the structure. It gives you a view of why you've documented it frozen in time as you off one of these loops. And that means that by the time you get your data sorted out and your feature engineering and you train your model and you want to do some prototyping to see if it's going to work or not, or experimentation, you know, in-house to check what's going on, then you need to have a view. And that's why the canvas helps you in a first step. The second step helps you then to figure out how you're going to deploy the data. In our clients, at least 80% of the time spent our partners to get products implemented is a data problem. It's disproportionately more important to understand that, because once you have a clear view of what you're getting, you'll be able to build out your process a lot slicker. And that means your project plan might have that point 2, so you can think of starting a few actions and then you're going to do those typically 2 or 3 times. And not even in parallel. You might do it in parallel across 2 areas depending on the data, but you will never stop. And even within each step, you keep on validating and checking and making sure that you've got the right capabilities, especially when it comes to data enrichment.
Any people in the audience who have some questions on things that they want clarified so far, please do pipe up. You're welcome to ask anything.
Whenever you create, let's say you're in a bank, a telco, an investment bank, or a retailer, you inevitably have a template that you have to complete that will help you to, you know, explain business value to the people who's going to fund the project. And you might hear language like BRDs, value proposition definitions, and requirements documents. Our view, at the end of the day, is understanding the value you're going to get from doing something different. And that means that when you embark on a journey, when you populate one of the, you know, your own canvas, you want to really think about, how am I going to explain to people what this thing does? And that's the value prop. When you translate your prediction story and your value prop to somebody and you explain it to them, the idea is that they should be able to walk away and be able to memorize what you said, and it must be even for you to memorize so you can explain it to somebody. So it's a bit like that's why I quite like the correlation of this look and feel to the business model canvas, because that's what companies do with their value propositions all the time. You have to give it to me as quickly as possible with a little bit of detail. When we work with the data team, you'll see that in the workbench, when you've created a project and you set it up, with all of your details, you're going to find that your data sources mostly, outside of your own environment. So that means that you might have a tenant running somewhere. You want to define where you get all your data from. Is it a file? Is it a stream? Is it some kind of data connection I have to go to? So that means that there are different approaches that you really have to understand in detail. And I think that mapping then onto the workbench or onto your Jupyter notebooks is quite important, because you know that you're going to have to do it again and again. The same thing applies for your prediction decision. If you look at the top left of the canvas, you want to explain where this will be implemented. We have use cases where the prediction of a solution to a customer is 1%, and cases where the prediction is 90%. Why can it never really be 100%? Because the prediction happens behind an API, it is behind some environment, and you need to give it life. The life is a chat front end or a user interface that's going to display a banner, or a website that is going to have a button appear or not appear. So that 1 degree removal needs to be understood from the beginning when you do your decision design of wherever you're going to be applying it.
I just wanted to ask, maybe if you could give us one example of what a sticky would look like under the ML task, and maybe one that would fit under decisions. Because here we've got...
If you look at input, output to predict a type of problem, what that means is the machine learning task. Let's say you want to predict the price of your product to a customer, and you want to bolt it into on your top left, you want to bolt it into your commercial front end or to your call center. So the machine learning task would be both procedural and predictive. What does that mean? That means if I'm going to get an answer from, let's say you use an ecosystem real-time recommender kind of environment, and you know that there are eligibilities. Eligibilities could be customer has to be of a certain age. They have to have earned a certain amount of income. They must be in a certain geography. They must be of a certain gender or race. They must be of a certain height. There must be whatever the value that you can measure against. It's procedural. It's got a rule environment. And you can implement it in a few different ways, but you can take those rules and put them into the runtime, into our scoring engine, and make it deployable as a single solution. But it comes with the machine learning task is not alone. You have a series of actions: check eligibility, obtain profitability review. If the profitability is over X, go to the first predictor. If it's over Y, go to the second predictor. So you can decide which machine learning model will be used and describe it in the ML task environment. So that's typically what you would do with that. So it'll be the prediction. If I want to predict, like let's say a score, like I said earlier, is that score something that is degree of some sort, so that it's not a score as in a continuous number, or is it a regression-based model? So you would sometimes, depending on who the client is, talk about what the model type is, because you would be looking at it in the bottom right anyway. You would decide what kind of model you'll be using. The machine learning task helps you make sense of the interface between what I'm predicting and what I'm making usable back to the person using it.
Great. I think I'm all clear on my side. If anyone wants to ask a question, now would be your time. But I think we've covered most of what we set out to do.
One of the last questions is sort of like, because this is a lot. It's quite a thing to wrap your head around. It's really, really helpful tool, but I think for a lot of people it's quite foreign. Is this something that has to happen in order to have successful product or project or use case be implemented? Or is this something that should happen but is not?
Absolutely essential. If you look at failures, even the failures we've observed, we've had commercial experiments that we've cancelled. We've not had failures as you would normally know in a use case style of failure. you could see that again and again and again, people did not think through the actual value that they're going to derive. I think there's a lot more attention being paid to it now compared to before. So that is a big consideration. You need to think about, what am I going to achieve with this? The other thing is that what is nice with this canvas is that it's a minimum of what you would need to look at to get a case to work. Because in our cases, every one of those blocks have got another 20, 30 items for us to get our projects to be successful. We know that because we've time and time again over case by case seen that you forget that certain items need to be present. And in this case, this is the bare minimum that must be present. And I feel that people build out their own sub-processes and sub-steps and, make those into a template is typically on the client side.
Thank you.
Before we close off, just a comment. I thought this was a great session to unpack the different aspects of the platform and the importance of the value proposition. I remember when I was working on this with Bodhi, I struggled to understand what we were predicting. It's great to see that it's important and my struggle was worth it. But before we close off, I do want to say that we are launching our very first competition as part of this tech series. An email did go out about it today, but for some information, it is an opportunity for people to submit their own prediction story and their own populated ML canvas with a project or use case of their choice. And the link is on our website. I will drop it in the chat before we close off. Competition launches today and the deadline is next week, Wednesday. Please, can we have all submissions in by then? The winning project will get the opportunity to work directly with our team to unpack the project, find it on this canvas, and build, test, and develop it in the Ecosystem AI platform. Look out for announcements and news on LinkedIn and in our newsletters. Thank you so much, everyone.